As we just had a great release last week, I thought it also could be a great opportunity to explain the new features that the Elasticsearch or the Elastic Stack 6.7 included. There are really some really cool features that I will explain here shortly, and some of them I will also demonstrate as well, so you can see how it works in reality. Has anyone here just tried 6.7 by any chance? Yeah, we have a few. Cool. Great. So let's start this from a component perspective. As Morten just explained, the Elastic Stack has the different components like the Elasticsearch, Log/Beats, and Kibana, which are the main components. And the heart of the stack is, of course, Elasticsearch. This is where we index documents. This is where we search and analyze the documents. And one of the key features that came out that went to GA, general availability, in other words, ready for production, is something we call cross-cluster replication. So we have several customers that want to be able to replicate from one index to another because of many different reasons. One could be for an obvious reason is like disaster recovery, right? That they want to store the data at a different location. So if disaster happens, they can fail over to the new cluster. And until 6.7, you could do that in different ways, but often you relied on other components that were outside the Elastic Stack. Some used things like a messaging queue or event broker like Kafka to basically replicate the data in two different clusters. And but with the cross-cluster replication, we can now do that, say, internally or natively, directly from Elasticsearch. I would also, just to make a note here, you see there in the kind of subheader, you have something called, like Platinum, and that's one of these commercial features that Morten also went through. I also present some open source and as well as basic features as example that are free, but that's just for your say, orientation. But basically, the cross-cluster replication allows that you have like a leader index that you write to. That's the active one in one cluster, and then you can do it on an index per index basis. Let us say a follower index on a remote cluster to subscribe to that and actually do the replication. And it's an active passive mode, so you can only write to the leader index, the active index, and the follower index is pulling data from the leader index on an event per event basis. The failover from, say, the leader to the follower is done manually today. That's how we implemented it, based also on the feedback from the community. I will show a bit how it's done. But one of the obvious use cases, of course, disaster recovery. If your production data center goes down and you still want to be able to serve the data, you can switch over to the disaster recovery site. Another use case that we also see among some of our customers is to actually move the data closer to where it's being consumed. So a very typical example we have in this is, for instance, in the e-commerce business. They might have like a central repository, like a central data center where they manage, say, the product catalog, but they want to push the data closer to their customers. So maybe they have a data center in Asia, Europe, and Americas. And they can then use this replication feature to do this replication out closer to the customer. Another is actually the opposite. I don't know how popular this one will be. Personally, I think it's like a say smaller use case, but you also have the obvious case where you have, or the opposite case where you have data located in your different clusters around the world, but want to move that closer to a central site. So you're not depending on that you have connectivity or that the remote clusters are up to be able to see the data. But it's also, say, at least possible to do this. So that's one of the key features. Another feature that we have been working a lot around, and it's actually quite a big feature if you look into the family, is around index lifecycle management. And there is a lot of different topics here, and I will try to explain this kind of puzzle here. But basically, when you size and dimension an Elasticsearch cluster, you do that basically along two different axes. One is, of course, how much data do you need to store on the cluster, the storage capacity, because every index, or in other words, which is actually a shard, a Lucene shard, have an overhead on the cluster itself. So you cannot have infinity much data on each and every data node. So you're always kind of limited of what we call the RAM to storage ratio. And depending on the use cases and your requirements, this ratio might differ. So you have everything from, say, 1 to 8, meaning 1 gig give 8 gigs storage for very, very, say, query response time critical use cases, or like heavy query use cases, to like a logging use case where you maybe are in the area of 1 to 100. So 100 gigs RAM gives you 100 gigs storage. So that's one of the parameters that kind of is considered during the dimensioning. The other one is the ingestion rate, that it needs to also be able to ingest and index all the data that you send it to it. And so you need to cater basically for the input ingestion part on the data nodes. And for that, we introduced a couple of years ago this hot warm architecture that kind of optimizes for both these parameters, ingestion rate and storage requirement. But you never came away from this thing that the RAM to storage ratio, independent if you have hot or warm mode, you're always kind of limited to this RAM to storage ratio. And for some customers that want to store data for a very long time, like maybe years or forever, basically that means that the cluster was growing bigger and bigger and bigger. And for some of them that want to limit the cluster size, we had one, say, alternative for them. It was to use what we call snapshots, basically backing up indices data to like a remote, like a file storage or an S3 bucket or something like this. But that meant that it was not searchable. So if they wanted to search that data that they backed up, they need to restore that into Elasticsearch cluster, do the query, and then purge the data. So it was not optimal from an operation point of view. So with the 6.6, the previous release, we introduced something called frozen indices, which means that the index, the data, is still on the data nodes if you have capacity from a pure disk perspective, but they are purged from memory, so you don't have anything, basically any overhead in the RAM ratio. The thing that you need to pay for this, because nothing comes for free, right, is that when you have a query that involves a frozen index, it will need to restore that into your RAM, do the search, and then purge it, of course. So you have a longer query time or response time of your query that you need to pay. So instead of, if we talk about milliseconds or maybe a few seconds, maybe we can talk about, depending on a lot of seconds or even minutes for a query that involves a frozen index. So this is what the trade-off that you need to consider. And so we have tested, so I mentioned before that in a typical logging use case, maybe we are about like a RAM to storage ratio of 1 to 100 approximately. And we have tested this internally, and we haven't really seen a practical limit in this. So as much as data you have on your data node, you can basically fill with the last index, but with a caveat, because the other thing you need to consider before you store all this data in frozen indices is also like a recovery time. If a data node with many terabytes of data goes down and that needs to be recovered on a different data nodes, that's a recovery time that needs to be considered as well, of course. So that's also, let's say, a limitation of how much data you can fill with a frozen index. And around this is also, of course, lifecycle management, how you can move data from, for instance, hot to warm to cold, or maybe even to a frozen tier then, like if you have specialized data nodes that are only having frozen indices. And we have had, some of you are familiar with a tool that's called Curator, which is basically an external tool that can manage your index lifecycle management for you, basically through you define like a cron job. So it's not that straightforward, But now, since 606 and 607, we are now moving this into the Elasticsearch stack, and actually also into the UI, so you can define this, the life cycle of an index, how it moves through your index, and eventually snapshot or burst from your data center. That's easier. So these are the operations that we are currently covering from the index lifecycle management in this, and that will also be expanded. So Curator can do a lot more things today, but this is catching up, of course. On the Kibana side, we had a new application. So if you noticed, almost by every release, we have like new icons popping up here on the Kibana side. So we had things like a graph, for instance, or infrastructure, and now we also have like a special application for maps or geospatial data. And what's new in this is also that apart from being able to search and visualize this on a map, that you can also do that with the different layers. So if you think like any layering function that you have in a presentation tool or a graphical tool, that you can lay this on top of them and you can switch them on and off, and you can change the icons and so on. So really powerful in visualizing and of your geospatial data. And this is also, to say, a beta one now in 6.7, and we are more than happy to receive feedback if you are into this space. Yes, there's another presentation on this. Another thing is Canvas. I will not present it too much here because I want to show it in reality as well, but basically it's a way for you to present data with pixel perfect reports like this. So you can use this for basically type of infographic type of presentations, but we're coming back to that. Yeah, for you that speaks Chinese or Mandarin, it's great news that we have now localizations. Until now we have supported, say, English only, but in certain markets requires localizations, and Chinese is the first one out that gets this. So that was on the Kibana and the Elasticsearch side. The Beat, which is, if you remember what Morten said, is this kind of lightweight shipper that you deploy on the edge where you want to collect the data. And we have a bunch of different flavors of Beats, depending on what you want to collect. Morten, where's Morten? Is he here? No. Did they go through the Beats, the different Beats? Because I was okay. So you have a bunch of different Beats depending on what you want to collect. So you have something like file beat to tail logs and chip logs from your servers that you want to monitor, for instance. You have metric beat to get the metrics from the services and infrastructure. You have winlog beat to collect window events logs. You have a heartbeat, which we're coming back to a little bit later, but basically pinging different endpoints and see if they are up and down for uptime analysis. And you have a new one that is now GA, which is the function beat, which is basically for serverless deployments where they can upload, for instance, this function beat into Lambda and get data, for instance, from CloudWatch or Kinesis or SQS as an example. So this is one of the first iterations. And we will, of course, include more cloud providers like GCP and Azure as well, of course, to do this. Another beat that I forgot to mention is packet beat as well. So to get you network data. An audit beat, actually. An audit beat collects audit logs from different systems. And one thing that we have focused on during the last releases is to make it easier from the collection to you actually visualizing and using the data in Elasticsearch. And we do that through what we call modules. So modules is like a shrink wrap, you could say, of certain things for, say, standards applications and services. And for AuditBeat, we have in this kind of system module that collects data from different data sets, like packages and host information, users and processes on the machines. It knows where to collect those on the hosts, as well as how to parse and how to map that data into different type of data sets. Let's say an IP address, and host name is a keyword, for instance, and so on. So it knows how to best, type that data, and then also how to visualize this data and how to actually use this in case of machine learning, for instance. How to run like some really basic machine learning jobs, looking for things like unusual processes that suddenly starts on your machines. So that's also something really powerful. It's something that is really good to see is the set of modules that we have that can help you to ingest your data from your applications and infrastructure. Logstash. So Logstash have a really powerful, it's like a Swiss Army knife, you could say, in the stack. So Logstash is used to have an input, and it has a filter, you could say, and an output. That is basically the three type of components of Logstash. And the input is like a vast number of inputs you can collect data from, from different event brokers, queues, and so on, to databases and applications, etc. And then you have filters to actually maybe transform and normalize this data. Maybe you want to enrich the data, calling out to external functions, ask for information, and enrich the logs before you eventually output it to either Elasticsearch or some other destination. But that's possible. And what's new in 6.7 is that now we can support to do this, write this, if you want to make your own plugin of any sort. You can do this directly in Java, in pure Java, instead of Ruby. So I think that's also appreciated by the community. Uptime. So I mentioned before we had this beat called Heartbeat that basically check with a list of endpoints to see if they are up and down. And to visualize and use this, we have also like a new application in Kibana called Uptime here to use this. And it's you can use it for basically anything. So you can deploy, say, Heartbeat on a central server and have a list of thousands of different endpoints, just checking are you up or down. And you can also, it goes with payload, for instance, and if have certain checks if they coming back, what type of response you get back from this endpoint as well. So you can do this in a very efficient and in a very scalable way. So it's something also that is really cool to test out. We also have an infrastructure UI, and this is especially for of course, an operations use case. But many of our that have their infrastructure on cloud and containers, they have issues. How maybe they have thousands of hosts and definitely thousands of different containers running on it, and it can be very, of course, volatile. Pods and containers goes up and down or moved to somewhere else. And it can be very hard to keep track of all your different services, what's happening and what to monitor. And one way to do that is through, of course, through FileBeat and MetricBeat to actually collect the data from the hosts, but actually to visualize it if you have so many different pods and hosts. As an example, you can do that through this kind of visualization where you have like a waffle map that you can see directly, have an overview of your infrastructure, and you can group it depending on what you want. If you like group it on pod or host or different namespaces, for instance. But you can through this have different color schemes to see that if there is some issue of any kind on your infrastructure that you need to be alerted on. So it's also like a really good feature for operations in cloud. Yes, how to visualize it. Another features is the logs solution. So a lot of users have, one of the main uses, of course, is to search logs, like a proper, let's say, search use case. And sometimes you just want to tailor logs as they come in, basically stream the logs through the UI, see if I do this in the application, what happens. You can see this basically in real time. And this is what the logs UI does. You can actually see the streams coming in as a stream. And you can, of course, use the search on the top to filter out if there is any specific logs from a certain host or application or any type of data that you want to filter out on. So you can do that directly here in real time. APM, the application performance monitoring. We're coming back to that on a demo if we have time. But as APM or application performance monitoring means that you actually install like a framework, like an agent within the application to instrument what's happening, what type of response times and transactions you do within the application, as well as errors, to quote unhandled errors and exceptions. That means that the agents, of course, are language dependent. So we have a bunch of different languages supported today. And one of the newest one is like a preview is the .NET agent to monitor .NET applications. So it's also therefore free to use. I can do a bunch of different demos, and it's what I was thinking too. It's not a sexy demo per se, but the cross-cluster replication. I was thinking, as it's new, it can be interesting to show it, at least see it how it works. You can basically, when I talked about that, you have like a leader index and a follower index. You can basically configure this in two ways. One is to actually follow an explicit index, that you say that this index I want to start following and replicate. Or you can do that against more like a generic, like an index pattern, let's say file bit dash asterisk, for instance. So I was thinking to show both ways. For you that are not so familiar with Kibana, we have something called the dev tools, which basically is an easy way to interact with the Elasticsearch cluster. It's basically kind of against the Elasticsearch REST APIs, and it's kind of curlish type of language here, you could say. So here's like a get HTTP command, for instance. It's the first time I'm doing this, so across at least live. So let's see here. So the first thing I need to do, this Kibana is now looking at let's say if we have like a central disaster recovery site. This is kind of the passive side, if I may say so. So what we first need to do is to connect to the remote clusters that want to follow. So we have one cluster in US and one in EMEA in this example. So first thing I need is to connect to those. So I need to go into management. I will actually copy this as well, so I don't need to type. Management. And in the management, you can see that we can all do these different management things, but what I want to do is to connect these remote clusters. It tells me to add my first because I have nothing connected today. I can give it a name of any kind, but let's give it to US to keep it simple. This is the address to the remote cluster. What was it? It's this. Let's see what is ES, right? ES US 9300. So this is the seed nodes from my the primary cluster. So if I say save, see if it's connected. It's connected. It's just a small one node connected, and then I need to add the second one, which is in Europe. And it should be ES EMEA on 9300. Save this one. So now we have two clusters connected to this, say, central cluster. So let's go back to the dev tools again. So the first thing I can do is to look at my my data that I have in the US cluster using this cross-cluster search. So this is what we talked about before there. But basically, I can see that I have on my US cluster, I'm searching against the file beat, and you can see that I have a file beat index there, which is now, say, daily index on this cluster. And as of today, right now, we have a bit over 1.8 million documents in this specific one. I will copy this index name because I also want to replicate it here, down here. I haven't been in PC. How do you paste in PC?
It's FN and B.
FN. Oh no. Oh, okay. No, I did probably not copy it. Sorry, I was. It's amazing how fast you forget. Yeah, there you go. So what I do now is say that now I, let's say, create the follower index. So I can just put a name to it, like follower, so you can easier to follow. And then I have this endpoint called _CCR, cross-cluster replication, and follow. So what I'm telling now is create this index called filebeat today's date and dash follower, and it should follow the leader index, which is this name, which is based in the US remote cluster. So if I execute this one, it gives me success. So it's like it's true that the index is created and it's acknowledged and it started to follow this. All great. So now we can have a look on my follower index. This is the follower index. Oh, sorry, this is hard for you to read maybe. But here's the number of documents that we have right now and how many megabytes we have. So if I see, you can see that we are following 73, 696. So it has started to replicate the data to my follower index. And you can also do pause the replication. So we can do that. Sorry. Follow there. It's true. And then you can show that it's no more documents are coming into the follower index. And then of course you can resume the same using this. And you get now documents ingested again to this. And so that's actually how simple it is. So this was, when you want to follow an explicit index, we start to follow this very index. So if I do it in this way, tomorrow when it actually probably writes to the 5th of April, that will not be followed then, of course. So the other way to do that is to follow an index pattern. An index pattern meaning like maybe filebeat dash asterisk, just to follow all the next coming filebeat indexes. And that is what you do here. So you go back to, and in the EMEA cluster, which is the other remote cluster we connected, we are a bit crazy. We're actually rolling over, meaning that we're creating like a new index, I think every minute right now, just to show you that it's following the pattern. So if I go back to management here, we go into cross-cluster replication. You can say that I want to auto-follow a pattern rather than an explicit index. And you can give it a name, replica. And here's the index pattern that you want to follow. So in this case, it's file beat --star. And you can see here directly that this is an example how it looks like. So you see that, okay, we have this kind of indices. And you can also, if you want to, maybe it's easier to add a prefix or a suffix of your following index. So we can just follow the previous example. Call this a follower index so we can easier to make it understandable. So if I press save here, you can see it's added that auto replica. And if I go back to monitoring here, we should be able to see documents coming in here. Just give me a second. So we go into the overview and cross-cluster replication. And we can see that this is what we're following. Yeah, and we can see it's on. We can see it's auto refresh it. And yeah, maybe we don't need to wait for a minute to another one to be created, but you understand the idea that when we suddenly have a new one, it might take some lag until we get the new one coming here. What you see here is actually the US, just realized. We can come back to that one later otherwise. There. So now we have the first, say, pattern that we follow, and then in another minute we have the next one. So you understand that you start basically subscribing to this. So that was on the cross-cluster replication. Any questions on this now before we move into another demo? No. The other thing I was thinking to show is the canvas. Have anyone seen it before? It's been out like a previews and pre-GA a few times before. So let me just log into my cluster here. And Canvas is also, say, another application in Kibana here. And Canvas is really like a presentation tool where you can create, now actually running on an older release than 6. I think this is 6.6 in my cloud. Yeah. So it's not beta anymore, it's GA. But it looks the same, probably some minor bugs. But what you can do is that you have all this is the different work paths, basically like presentations, you could say, if you look into another presentation tool, and which you can duplicate and you can download it. And when you download it as a JSON, so you can actually download it, you can email it to a friend that imports it here and sees the same thing from your view. And you can also add templates. So, I mean, many organizations and enterprises have like templates, the look and feel, how it should look like. So you can have those things. So it's basically what you could expect from any, say, presentation tool. And when you start on creating a Canvas presentation, you start from an empty canvas. But basically, you can choose, of course, which resolution that you want to have. If you want to have it in landscape or in portrait mode, or how many pixels wide and height. Of course, background colors and so on. And that's we're coming back a bit to how you actually create one. So let me first move this into full screen mode. I don't know how to do full screen. Yeah, this is maybe full screen enough for now. But basically, what it is like in this example, like this is, say, always fresh information. So when I present this presentation, just as a good example is that I never need to update the date here. It's like always taken from the time in the Unix time, for instance. But what is Canvas? And Canvas can really be anything you like. It can be very simple, that you probably have some KPIs or goals and objectives that maybe you want to visualize in your organization, and maybe you are striving for. So it could be like one KPI, one metric that you want to show in your coffee corner on a screen, for instance. So it can be like this. Oh, I should also have turn on, refresh. It's like the whole idea. So it's constantly refreshed. And what's behind this is, of course, is live data as it comes into the Elasticsearch cluster. So it could also be, there's more, complicated type of presentations. So whatever you see is like, you can do whatever you like. So you can put, if you compare it to, say, a dashboard in Kibana, which you have these gauges and time series and so on. They are very NOC-like or SOC-like, something that an engineer maybe understands. But if your manager is looking at that, he will probably not understand it, or a C-level or something, or any consumer or so. But with Canvas, you can put everything in a context. You can describe in text and images what are you actually looking at. And you can show this through this kind of image repeat, for instance, that depending on how your goal is. You can have everything here is like dynamic data, always fed as the data is coming into the Elasticsearch. Or it could be very nice looking things. This is a bit say doomsday picture, but here we're ingesting data from NASA, looking into meteors and other things in space that are, say, close enough to Earth. But this is, of course, also, say, updated dynamically. And you can actually use any type of, say, look and feel that mimics or presents your organization in that sense. So you can do these kind of cartoon-like things. And this is usually, when I talk to customers, this is usually, say, almost the biggest hurdle. They need to talk to someone in the market that actually makes the graphics in the end. It's actually not showing the data itself. That is the hardest part. And you can do things like field grade things, like presentations, and you can have pure animations. Everything is based on HTML and CSS, so it's nothing strange. You can have more, say, useful stuff than coffee. That for instance, monitoring your GitHub and pipeline commits and so on, and see what's happening, what type of activities running in your pipelines. So basically, what is Canvas? This is actually anything you want, to be honest. We haven't even thought about all the different use cases we can see, but some typical things would be like reports or infographics and reports and so on. I think it's better to show it, how it works. Yeah. So this is the presentation we were talking about. I will just turn off refresh for the moment. And here we have, say, my presentation, like you expected, that I just went through. And maybe you want to add like another page to this. So we add a page. And everything you add on top of this, you add through this manage assets. So when you do that, you can add all the different type of, say, pictures that we just had in this before. You can have this kind of conditional picture as well. So you have, if you have a happy face and a sad face, you can set like a condition. If X is higher than Y, show a happy face. If it's else, show a sad face, as an example. And you can add what we call elements that connects the graphical thing to your data in Elasticsearch. And you have a bunch of different elements to choose from. As of today, you have different charts and plots and tables you can do. You can also add like a drop-down filter, so you can add, say, interactivity to it as well. So if you, for instance, having goals, you can maybe let your users filter on department or whatever it might be, product, etc. You can do this kind of progress bar charts, just a static image, image repeat we saw before, or reveal, or markdown. Markdown is just for adding text or dynamic text to it. So in this example, let me add a markdown element. And every time you add an element, it always comes pre-populated with data, just to be able to see that you actually added an element. Otherwise, this will be, say, empty. And I have two things here. So one is that I can say on my right side here, I have like a panel where I can work with how it's getting displayed, but also what type of data that is getting ingested into this, or what data this element is taking from. So the first thing you can see, that it's actually saying that this data table contains 1,000 rows. Can you see there in the back? It will get bigger soon. Just give me a second. But it's also not also pre-populated with demo data to be able to show some data. So the first thing I will need to do is to change this to another data source. So you can use this demo data as of today. You can query Elasticsearch directly, or you can use something called Elasticsearch SQL. You can see that it's also pre-populated with a select statement. Now I need to actually cheat a bit. So what I did there was that I changed my data source from this, the demo data to actually make a select statement against my Elasticsearch cluster. And what I did is I do a sum of, we have a field in my data called textless total price. And I pipe that to a column that I call total, a name now. And I take this from an index it's called Kibana sample data e-commerce. But that's basically what you do. I need to make it smaller again, otherwise I don't. So, and when I did this, when I say this, it also said that this table contains now one row that is containing this column I just created, total. And yeah, and so now we changed the data source. Now it's saying, how do you want to visualize this data that we just get from this index? And you can do that in two ways. One is to, of course, start editing the content here that is now, say, populated in to the left here. That is probably the easiest way to do it here. But I also want to show that you can also do it directly under the hood, say. So under the hood, you have the expression editor that shows what is actually happening behind this. You can see that my query statement is here, and you have the rest of the statement here. So I will just delete all this stuff here down to this, I think, and I'll make it run. Yeah. So now I removed the rest of the markdown content, and what is left is my column and the actual value, the sum that we just did. So the next thing is, of course, how do we make this something more useful? And we can add, let's see. Oh, good. Sorry, I will see. Let's see, sorry. Markdown, just to make it, see. No. Anyone knows how many curly brackets on Windows? It's off. Oh, maybe that's. You know how to make a curly bracket?
I know how to make a curly bracket.
Good.
It should be.
I'm using Mac, yeah, so I know how usually.
Yeah. So FN alt and then 7 and.
Oh, do you? Okay, you had actually. Okay, cool. Thank you. Sorry about that. So what I want to do is to make this number a bit more useful in my presentation. So I will round it off, first of all. And I would take this total and also divide it with 1,000 to make it in thousands. And I want to have 0, say, decimals. And that should be it. So let's see what happens now. Ooh, yeah. So, and this is, by the way, this is the advanced version. So don't be frightened now. It looks cryptic for you guys. But so now I have my textless price, the sum of my textless price, what we have sold in this number in thousands here. And then of course you can go back to make it easier for you to actually work with this again. So let's go back to this site so you can change text settings, for instance, how it should be visualized. You can do things like anything you expect in a presentation tool. You can change it. So nice and big. You maybe want to add some other elements like shapes. And as you have in other, you have this kind of alignment tools and centralizations, things that helps you. And you have this kind of layer approach. So if I put it over, or I can put it into the back. Sorry. I can move this to the center. And I can change. Make it maybe yellow. Maybe I want to have it round. This more center. You can clone things. So I can clone this and maybe change the shape. And by the way, this is what I have rehearsed. So I only do this presentation. Move it back. See what I'm getting to, like medal. And you can clone this, and it's fantastic. If people think, are you doing this on the fly? And so the other way, before we were editing down here, we can actually close this expression editor. But editing this, we can actually done it as simple like this, just wrote what we wanted it to say and the numbers and apply. So this is, of course, the normal way to do that. So we're doing well in sales, 351 millions. Just today. So this is how simple it is. And we can add another element. Let's do a bar chart, horizontal bar chart. Again, when I added this, it comes, say, pre-populated with this demo data. So the first thing I need to do is to change the data it's pointing to. So change the data source. Before we use this Elasticsearch SQL, I will now do like just Elasticsearch query. I choose which index I want to collect the data from. This is the e-commerce index. I can write a query here, or I can just choose which fields I'm interested in. And it's in this, say, textless total price that we had before. But maybe we want to see which countries are doing well or which cities. So geolocation, I think city name would work. So if I say that again, it becomes empty because we haven't told how we collecting these two fields, but we haven't told how to, say, visualize them. So again, if I move up here, I can say, go back to display and say that on the x-axis, I want to have the sum of textless total price. On the y, I just want to have the value of GeoCity name. And maybe I want to have a different color based on GeoCity name. So there you go. And you can also, of course, go into more, say, look and feel. You can maybe say that this this color palette doesn't work for us or for me, so you can choose something different. Let's take elastic blue. Yeah, nice, huh? Maybe I also want to, maybe x-axis, maybe I don't want to show exactly what the different are selling, so I can just turn off the x-axis, so that one goes away. But this is basically how simple it is to start making Canvas presentations in a way. So it shouldn't be too hard. Yeah, I would say. Any questions on what I just showed you here? If I go, yeah.
Can you export the presentation, not as a Kibana, but you would say as a static PowerPoint?
Yeah.
Probably many of your
Not
audience would like it.
not yet. Actually, I haven't tried it in the latest version 6.7, to be honest. So the question was, can you export the presentation into some static format? Could be like anything, but like in as a image or like a PDF or something. And that's what you actually can do in our, say, normal dashboards in Elastic or in Kibana. You can export it into PDF or PNG or CSV if you like, as an example. But in Canvas, I don't think yet you can export it in a static format. I think that is probably on the roadmap to do that, but I haven't seen that yet. But on the other side, I'm actually running now on 6.6, so, but I haven't heard that this is part of the feature set yet.
It's already a web page, so very simple.
Yeah, exactly. It should be super simple. So it shouldn't be.
To export, just press Control P.
Yeah, exactly. Yes. Yeah. Another way. Yes.
Can you reuse the existing visualization somehow inside the canvas?
Yes. You mean like, or how do you mean with reuse?
So I mean, if you've already built a bunch of visualizations and dashboards, is there any way to import the visualizations that you've already created in that part of Kibana into a canvas?
Oh yeah.
Recreate your visualization specifically for the canvas.
Yes, you have to recreate it specifically for. You cannot take a visualization that you built for like a dashboard, for instance, and import that into Canvas. No, you cannot. So what I will do here is let's show APM, and just to give you some context to this as well. So today you talk a lot about what we call observability, that you be able to have like a 360 degrees observability is kind of the buzzwords. And as of we had, of course, the logs. So we get the logs, so we can see that, okay, the endpoints, the response is 200K, everything is good and great. We have the metrics from the services and so on that gives you kind of that insight. But you still didn't see really how the performance was. It's really hard to make those kind of judgments, at least. So that's where the APM comes into place. This is kind of the third leg in this trinity of observability, that you have the metrics, the logs, and then the APM data. And that is from one tool. So you can correlate your logs with APM data and the metrics, and that makes it very convenient. And you can run things like anomaly detection to see anomalies in this data. So it can be super interesting use cases on this. So what this demo is to focus on one of those like, so of course, it's with APM data. And just put some context in this as well, is that we are running like a pet clinic shop with veterinarians and stuff. So we have like a website. And just to give you some bit of infrastructure, we're running on Kubernetes, where we have like a 3-node or host cluster. And the front end is powered by React, and it's run on top of Node.js. And the Node.js is then, say, depending on sending the next request either to the next tier, which is either to to a Spring layer, to the Java, or to a Python Flask layer, which is done for an application we call Address Finder. So the Spring is more, say, the business logic, and it also has like a persistent layer underneath using this database, MySQL here. And the Python is using Elasticsearch for Address Finder or address lookups and so on. And on all these different machines, we are also collecting data. So we have this beat, so we're collecting the logs, of course. We collect the packets, what's happening on the network, metrics, what's happening on the machines, as well as audit data. So we're getting audit alerts. Plus, we're getting the APM data, what's actually happening within the application. So just give you some, say, context, so what you will see here. Yes, so we have, say, an APM agent installed on the React, on the Node, as well as, of course, Python and Java here. So basically, we're collecting all these different layers into Elasticsearch. And just for make it simple to demo, so we built like a dashboard here, which kind of mimics an email inbox. This is of course not real, but just to show an example. So you can use things like machine learning to tell you that something is bad or something is different from what it used to be, something that you should look on. And this is what's happening here, that we have like a machine learning job that looks into the performance in what we call in the RUM, in the real user monitoring. So how is the performance on your users' browsers? So we talked about before that the application maybe gives 200 OK, but you don't know, you cannot see that the response maybe takes 10 seconds until you get a 10 OK. So the performance might be bad, and that's really hard to see just through logs. This is what APM gives you. So you get this kind of automated this email in this case that's saying that users are experiencing slower than usual response time. This job detects performance in the browser. So you can click here to investigate further. So I will just open a new tab to make it easier for me. So it takes you into what we call the machine learning application in Kibana. And machine learning, what it does, it just looks for anomalies, things that are out of order, let's say. So it learns the cyclical pattern. We probably have very low usage, for instance, during weekends, and then we have the ups and downs during the weekdays, and different users might have different type of behavior and so on, and different transactions in our applications also very differently depending on what they're doing and what they're interacting with. So we are, say, we're learning the history for each and every transaction, depending on the time of the day and etc., of course, but also the transaction itself. So on this page here, you have something called the anomaly timeline. This is the overall, over all my different transactions. You can see that white is that everything is normal, or light blue is like very little abnormal. But then you have, say, on a grading scale up to red, which is the most severe, say, anomaly that has been detected. And that was also what we were alerted on in this email. And so it doesn't say anything is bad. It's just saying that something is very different suddenly on response times, for instance. It looks for high mean response time, this job. And it doesn't only point out that something is very different. It also says that it also gives you a context to the anomaly. So it can give you some clues, for instance, if you want to do root cause analysis, saying that for this anomaly here, if I click this, it filters out. We have a user called Dalem is very influential to this anomaly, and it also it's also to a specific transaction called update owner. So these two are the things that are kind of the main cause to the anomalies. It directly gives you clues if you want to do root cause analysis. And you can also go into single metric viewer. I will just move this quickly because time is running. I want to show you everything. So you can, even if you have a bunch of different transactions through your application, you can of course filter here. So yeah, you can filter on update owner. It was this one. And you can see that this is the norm on a timeline. You have this very low value, and suddenly you have like a peak on response times on this transaction, and then it goes down again. So of course, you can see just by your eyes, it's very anomalous, right? But let me go back to the Anomalous Explorer. And we can see directly from here that if you break down and look into per transaction basis, you can see the top 10s here with anomaly scores is that the update owner, which is one of the transactions, is anomalous, is the one that is anomalous. And you have the same view here, then, of course. And what it tells here, I will increase the font size. Just give me a second there. Okay, what it tells here is that the typical response times should be 38 on update owner, but suddenly it has almost 100 times higher than normal, and that the algorithm calculates the probability of that to happen under the hood. So it gives you like a very mathematical probability, 8.4 times e to the power of minus 16, which is a very low number, but it's very hard for us to say take in as humans. So what we do is that we normalize the kind of probability into like a severity score. It's between 0, which is normal then, and 100, which is most abnormal. And this is 94, so it's on the top. Okay, it does. What we only know now is that this transaction update owner is experiencing, say, unusually long response time, mean response times. So, and it involves the user Dalem to it. So the next thing is you can start this. Okay, analyze what is causing this. So you can go into from the anomaly into the APM view. And the APM view, of course, filters, take this, the kind of the context of this, say the timing of this, for instance, into the place. So you are, say, pre-filtered in a way when you come here. This is the APM UI. And you have a lot of different things here, like response times and transactions that happens within the application. I will zoom in here. So here you have the response time. So you have average, 95 and 99th percentile. I will turn off just to make it clear for you guys. So here is only the blue is the average response time. And I can zoom in here as well, so make it clear for you. You can see that this red band also means that it's anomalous. So machine learning is also marking here that here we have an anomalous high response time. If I scroll down here a bit, I have the number of events, and you can also see that this transaction we were talking about, this update owner, you can see here with your bare eyes that this have a very high impact. Is on the top. It's the average response times is 3.5 seconds, or say the 95th percentile is almost 13 seconds. So it's definitely something going on there. So let's go deeper, drill down deeper into what's happening here under this update owner. And now you come into something, the two things that we should look into here is like, this is the response time distribution. For this update owner transaction, you have like a distribution of the different response time that is collected. So most of them are executed very quickly, let's say between 0.0 and 0.2 seconds. You have 16 transactions there. So most of them here, but you can also see that we have a few outliers. Some are taking like more than 13 seconds. And if I scroll down here a bit more, you can have this kind of distributed tracing, this kind of waterfall model. So you can see that how this transaction update owner, how that say transacts through your application stack, through the React layer, to the Node layer, and finally to the Spring layer. And this is then color scheme with blue, green, and purple. So if I take say the quick example and look at the stack trace here, you can see that this one goes very quickly. From the whole transaction takes 35 milliseconds, and you can see, and we're coming back to this later, that this validate zip code is very, very quick, extremely quick. So, but if I go back to a bad case, which takes the whole transaction takes more than 13 seconds, it looks a bit different. And you can see that this validate zip code takes the whole time basically, and then hardly update the owner gets executed. And you can drill down further into this and look into this span of let's say validate zip code. Why is this taking almost 13 seconds, which is almost 99% of the whole transaction time? And you can see where in the code this is involved. So you can go back into your source code and start investigating. Or you can go up to, say, your owner transaction, the parent transaction, and look at that one. And you can see that on this transaction, you can see that this has actually, you got like an error, like a 400 error. And if I click down there, you can actually see that the actual response for this particular transaction, you can see that it's a 400 status code error. And you can also see that this user, Dalem, has entered a ridiculous long zip code. And our developers, in this case, has used regex to validate zip codes. So this has taken a long time, and finally, of course, timed out. So we can actually replicate this. Just give me one more minute. Replicate this through our pet clinic as well. So if I go back to my, this is actually the user UI. So if I want to update owner, so if I want to edit the zip code, and if I start adding a few here, that one goes pretty quick. But if I add more, yeah, it will take a long time. And you can see that you can validate this, and then you can actually go back to the APM UI again and actually go into and see if we can see those kind of errors I just created through this replication. So if I go back to APM and go into React and see the errors here, and we can search on my username. Let's see, it takes some time until it's in here. I think that's still.
See the time scale in the upper right.
Yeah, exactly. I think. Yeah, exactly. Oh, wow, great. That's. Thank you. So now you can actually see that you have, say, you can get, yeah, you can see that those errors I just created are, say, replicated or actually handled here as well. So there are more to this, of course, as well, but this is really cool when you can start correlating logs and metrics and logs and also apply, say, anomaly detection on top of this. So I think that's the kind of the idea of this. Cool. Now it's back to, that was the end of the demo. Any questions before we move on? Yeah.
Do you guys have any numbers on the cost of the APM collection? Because that's actually interfering with the programs, right?
Yeah, you have some kind of observability cost, I guess.
Exactly.
No, I haven't really heard about that. We can check it with the OPM team here in Copenhagen, but no, to be honest, I don't know. But maybe we have some answer on that, but I don't have it yet. Cool. That's it from me. So now we have a break where you can ask me anything, AMA sessions, or Morten, if there's anything commercial or anything else here. So maybe a refill of some coffee or water and so on.
There's cake outside.
Yes.